Hello and Assalamualaikum everyone. So today our group will present about chapter 4 from Fabrication and Welding Engineering books, which is using and communicating technical information. So before we proceed our presentation, let me introduce our team members. Firstly, myself Muhammad Haris, Chong Wen Chen, Diana Jane Lauren and also Muhammad Hakim Hasyun.
Hi, my name is Muhammad Hakim Hassun, and today I will be presenting the selection of information sources. First of all, the information given in writing includes training logbooks, stock lists, technical data, and also manufacturing instructions. Next, we have verbal instructions. Verbal instructions and phone messages should be confirmed in writing or by fax. Fax is particularly useful for instructions involving illustrations. Next, the goals of information production is that it's easy to understand and also minimizes errors, and it's also quick and easy to complete. Next, we have standardized forms. The use of standardized forms aids in achieving communication goals. Boxes requiring ticks eliminate the interpretation issues with handwriting. Lastly, achieving organizational goals. First of all, manufacturing organizations aim to deliver goods at the right price, quantity, and time. It also requires teamwork, close liaison with customers and suppliers, and efficient communication and handling of engineering information. Uh, so for the next subtopic, interpretation of graphical information. The factors for method selection is included nature of information, the required accuracy of interpretation, and also audience expertise. Um, First of all, we have to choose the right graph, considering the data's characteristics and audience understanding. Select the graph type that best communicates the intended message effectively. So this is the example of line graph. You have both smooth curve and also a straight curve. Uh, so for the explanation of curve A, graph A, it's a continuous curve, which means points related by mathematical expression. And for graph B, there are multiple explanations, straight line, curve section, stationary phase, and also reduced speed. So this is example for histogram. This is an example for ideograph, pie charts, and also a bar chart. Okay, so for 4.3, interpretation of information, manufacturer's catalog. Manufacturer's catalogs and technical manuals are vital for staying updated with suppliers' product lines. Regular consultation of catalogs and manuals ensures up-to-date knowledge, supports informed decision-making and efficient operations within the organization. 4.3.2, British and European standards. For historical context, Industrial Revolution led component standardization. Nuts and bolts were individually made and non-interchangeable. Secondly, the international standardization. International Standards Organization (ISO) formed in 1947 to harmonize national standards. Second, it aims to promote international trade and quality consistency. Aims of standardization, also defined by BSI: efficient communication among all parties involved, promotion of economy in production, and exchange of goods through mass production of standardized components. The significance of this is that standardization enhances efficiency, quality, and global trade. It also ensures compatibility, reliability, and safety of products and services across borders. For production schedules, we have three types: visualization tools, monitoring progress, and also regular update facilitates. So for product specifications, comprehensive production specifications and works orders are vital for smooth manufacturing processes. These documents detailed materials, production methods, schedules, assembly, and testing. It also benefits include clarity, reduced errors, and effective task execution. So this is an example of the work form usually used by companies. Okay, next, 4.3.5, reference tables and charts. Pocketbooks are published for various branches of engineering, including those used in manufacturing workshops. They also include standard screw thread and threaded fastener data tables, as well as tables for spacing holes around pitch circles. Additional information includes speeds and feeds for cutting tool and workpiece material combinations for different processes. Next, drawings and diagrams. Most engineers utilize drawings and diagrams as communication tools with both fellow engineers and the broader public. The creation and interpretation of engine drawings are essential skills which will be discussed further. So last but not least, 4.4, evaluating engineering information. If a work order suddenly specifies a different material from what was previously used, question whether it's a genuine change or a clerical error. We also have to ensure that standards referenced in production are up to date, as specifications and regulations can.
Assalamualaikum and good afternoon, Doctor. My name is Lauren and I'll be presenting on the recording and processing engineering information. So, firstly, it's on the quality control. A firm that wants to sell its goods to a BSEN 9000 approved firm must first be approved and obtain its supplies from approved sources. Next, all the products need to fulfill the customer's requirements must be clearly identifiable through documentation. So this step actually helps keep track of the parts delivered to customer from the source. As you can see in the figure on the right, this is the overall flow of the whole exchange. So it starts from external supplier to stores, Department A, Department B, inspection, dispatch, and finally to the external customer. Next is on the health and safety. Firstly, all accidents must be registered. Then, regular inspection and certification of lifting tackle and pressure vessels, such as boilers and compressed air receivers, must be um, certified. And all the dates of fire drills and time taken to evacuate the premises must also be noted down. Lastly, is on the legal and financial reasons. So, registered companies must publish their memorandum and articles of association and also submit a copy at company's house during setup. And all the minutes of meetings of the boards of directors must also be noted down. Furthermore, is on the methods of record keeping. So, this is done through three methods. Firstly is on the computer files. This has become a pretty common practice in the world these days. Next is on the microfilm and microfiche. And lastly is on the registers and logbooks. So this helps keep record of the training undergone as well as comments received on your performance. Next is on the communications. Firstly is the safety and hazard signs and notices that should be instilled in all and any plant sites. So these are some of the signs that should be available, such as warning, danger, the use of safety helmets, ear protectors, warning overhead loads, high visibility jackets, protective footwear, and unauthorized entry. Next is on the color coding. This is split into three parts. So firstly, it's the cylinder content. So the color here indicates what type of gas is inside of the cylinder, as you can see from the figure here. Next is on the electric cables. So the color here indicates what type of services these cables are attending to. And lastly is on the pipe content. So over here, the color indicates what type of content is traveling to the pipe. So as you can see from the figure on the right, this is the type of different methods that these pipes are colored. So firstly is the whole pipe is painted. Next is just the panel, and then it's just the colored label and sticky tape, and lastly is colored bands. The last topic for my part is on the engineering drawing, the introduction. So these are a drawing of a simple clamp. So firstly is on the pictorial drawing, which is a general drawing. Next is on the orthographic drawing. So this allows different views of the clamp from different direction. It allows every feature of the clamp to be seen and also those that can't be seen, which is indicated by the dotted lines. Lastly is the fully dimensioned in millimeters. So as you can see here, the drawing is fully labeled with its dimensions. That's all from me. Thank you very much. I'll now pass it on to the next presenter.
The first angle projection is known as English projection as the object lies between observer and plane of projection. The right side view of the object is to the left of front view and the top view is at the bottom of side view. For the first angle projection symbol, we can see the object is located at first quadrant where the side view and top view was shown. And since the front view is same as the side view, so the front view was ignored and the side view was shown. We use this example to demonstrate how to construct the first angle drawing. So initially, we need to draw ground line, vertical line, and planes. And next, we can continue to draw the initial construction lines for the top, side, and front view of the object. After that, we need to line in the outline with thicker line to show the object's shape and dimensions. For the third angle projection, it is known as American projection, where the plane of projection lies between object and observer. The right side view will be at the right of the front view, and the top view is at the top of side view. For the third angle projection symbol, we can see that the object is located at the third quadrant, where the top view and the side view were shown. And since the front view is same as the side view, we can just ignore it and the side view was shown. Here are the steps to construct the third angle drawing. We use the same object as the first angle to demonstrate. So initially, we just look down on the object and draw the top view above the side view. And the next is look at the left hand end of the object and draw the end view at the left of the side view. For the conventions, it is a way to produce engineering drawings and sketches by utilizing the standard conventions. It is based on International Standards Organization's suggestions, so the drawing using conventions and guidelines are accepted internationally. There are two types of conventions. There are types of lines and abbreviations for written statements. For the types of lines, here there are lots of different lines with different description, with different applications. And here are the abbreviations for written statements. This is the example of abbreviations for written statements. We can see the written abbreviations shown above, saves having to include all the dimensioning shown below. For symmetrical component, not every view is necessarily required to convey the manufacturing information. Like a ball looks same from all directions, so depicting it with three circles arranged as a top view, side view, front view will simply be unnecessary. Just need to draw one circle and a note that the component is spherical. This is the example of redundant views. From this first angle drawing, the top view is same as the side view, so it is reduced to two views as the side and the front view. After that, the drawing is reduced to a single view by using resolve section and BS conversion for the square flange.
So hello. For my parts, which is firstly dimensioning. So drawings must not only depict the shape of components but also their size and any features, and also including dimensions on the drawing is essential for any manufacturing and also to prevent misinterpretation. The dimension should follow the guidelines set by the relevant British standard to avoid any confusion. So next, we can see typical conventions for some common features, and then we also can state the correct dimensioning, which is the dimensions lines should be thin full lines, not more than the thickness, and also wherever possible, dimensions line should be placed outside the outline of the drawing. The third one, the dimension line also head must touch but not cross the projection line. And dimension lines also should be well spaced so that the numerical value of the dimensions can be clearly read and so that they do not obscure the outline of the drawing. Next, we also can see the incorrect dimensioning. So from this diagram, we can compare the correct dimension, which is the ladder lines are used to take the dimension outside the drawing, and vice versa for the incorrect one. So next, for the welding symbols, so From this figure, we show two types of welded joints, which is firstly the butt weld and also the fillet weld. So most manually welded joints are a variation on these techniques, which is drawings involving welding must give all the details necessary to specify the type of weld. For example, edge preparation, fillet material, type of joint, length of run, and also size of weld. So next, this is several example for the British standards drawing symbols. Okay, this also the example for the sketch of welding and also their symbolic representation. And next, for the development of surfaces, we have three basic methods used in pattern development, which is for firstly the parallel line method, and then radial line method, and also triangulation method. So firstly, the parallel line development. So the parallel line method of development relies on placing the pattern shape on parallel lines, which is used for any object with a consistent cross section throughout their length, like prismatic components. So we can see at this diagram, which is EF and it exists at 90 degree angle. So this is the example of the diagram. The second one is radial line development, which is also applicable for frustums, which is would taper to an apex if extended. So these some examples of the radial line development. And lastly, development by triangulation. So it involves dividing the component surface into triangles, which is determining their true size and shape and arranging them to create a pattern. And also, we can see after this, the example include developing a truncated cone, which is frustum. So this is the example. So next, interpenetration. We divide this into two, which is elbow and also coaxial interpenetration. So we can see angle coaxial interpenetration and also elbow comparison examples. And next, okay, so next we also have pictorial views, which is divided into two, which is firstly oblique projection, which is basically we can solve from this diagram, which is one face is drawn true to size and shape, while lines receding into the page are drawn at 45 degree, and also to improve proportions and realism, receding lines are drawn half their true length. So compared to isometric projection, from this figure 4.4, we can see that it displays a bracket in isometric projection with axis drawn at 30 degrees Celsius to the baseline, which is strictly accurate isometric drawing should have receding lines to isometric scale for practical purpose. So that's all from us. Thank you.